Well, hello everybody. Today we are going to do something else on this channel, and it's another hobby of mine. This time this is a hobby, not actually my job. So what are we going to do today? Today we will try to build a Zigbee coordinator. So actually this project belongs to some guys in Russia, and the developer of this board and what you will see further is Alex Egoni. I hope I made it right. Anyway, I will leave the link in the description to his GitHub page, where you can find everything related to this coordinator. Okay. Another thing to say is this coordinator will work with zigbee2mqtt, and it should replace the older Cc2531 sticks that are limited, I think, to 40 devices, and this one should handle let's say, at least in Coenx firmware, it says 200 devices. So all the parts that I have from the link that I will leave in the description, and if you want to do the same thing, you will find all the links there to all the products used in this video. The reason why I did this, I also could have bought and ordered this kind of coordinators from Tindi. There are two sellers there that sell these products, but at the final price, with taxes and shipping and everything to Romania, I found that it almost covers the cost for me to build, let's say, 2 or 3 coordinators. And this is what motivated me. And another thing, just recently, I mean for 1 or 2 months ago, Coenx, the maintainer of zigbee2mqtt, with its firmware, it's supporting these sticks, and well, you can also flash them to be a coordinator and also a router. So if you have a bigger house and just the coordinator is not enough, you can also build, let's say, another stick and flash it with the router firmware, and this will act as a router. You just need to plug it into a USB charger or a USB port like this, and place it anywhere in your house, and it should act like a router. Okay, so the components. The first thing is the printed board itself. As I said, the files for this board are available in the link, and I just downloaded them, went to PCBWay, and I ordered the boards from there. It took about 2 months to reach me, but I could say that I ordered 10 boards, and the 10 boards were I think $5, and I think it was $1 shipping, if I'm not mistaken. So 10 boards for let's say $6. So this is the one of the components that we need. We also have here the wiring diagram of the coordinator, but I will not bore you with this because you can find it in the links. And we have here every component that we need for this stick. We have this little current or voltage limiter, I think, and this will convert 5 volts to 3.3 volts. I think this is what it's supposed to do. Okay, I will just put them back because otherwise it will be a mess when we are finished. The next thing that we need, this part is actually a serial converter, I think, but I'm pretty sure that's what it does. So this little part will translate the USB signals to serial ones. Okay, next I don't think I will put everything out here because it's just not worth it. We have two types of bigger condensers, as you can see here. These are really small and will require some quite some fine work just to solder them on. So we have two types of condensers that will go here on the board. Yes, here and here, and probably if you will look you can see on the pictures in the link. We need two buttons. One is for reset, one is a reset button, one is flashing, and the main component of this is this module from eByte, and this actually has inside Texas Instruments CC2652 chip, and this is the radio emitting part. Okay, and what else should we mention? Some resistors. There are two types of resistors. There are 1 kilo ohm resistors and they are 10 kilo ohm. Actually, this one is 10 and this one is 1. So it's good to have them labeled, but actually on this you can still read the code and you can find online the value of it. So even if you mix them up, it's no problem. You can still figure out which one is which, and the size of this is just like a little bit bigger than I don't know, rice, maybe even smaller than a grain of rice. Okay, so these are resistors and these are condensers. With this you will have to be careful, because if you lose the label and if you order, let's say, 2 or 3 different values, if you lose the labels, you will, I think, only with a special condenser measuring multimeter you can find out, because there's nothing no mark, nothing written on them, so just be careful with this. Okay, aside from this, we need two LEDs, two LEDs. This is the set I ordered. Of course it has a lot of, I think 50, 20 picks each, and there's 100 LEDs here, and they are different colors. The ones that are described in the documentation says green and red, but it's pretty much up to you what color you will use. It doesn't really matter. One thing to say, that Coenx firmware does not support LEDs, so they will not light up, but on Alex's firmware they should work. Okay, what else? Yes, we have the USB connector here, which we will put here, and I think you from the descriptions and from what I read, I think you can also use micro USB, so again it's up to you, but I use this one because you can plug them directly into your computer rather than using micro USB. Okay, so what else? Yes, we also have these antenna connectors. This can be used with or without an external antenna, but because the chip already has here the antenna, and if you do not want the external antenna, then you need to break down this part of the board before you install this module. Okay, I will make them with the antenna, and finally the antenna that goes here, and that's it. I think here you can choose which type you like. These were cheap. This, it says 5 dB, but I don't know, maybe if you want something stronger you can buy a bigger antenna. This should improve the range. Okay, so do we have anything else here? No, not for this project, so that's about it. Okay, we will go ahead and assemble the stick. I must be straightforward with you. I already assembled the stick before I'm filming this, and I'm really sorry that maybe you will not see some parts correctly, but anyway, we will speed it up so it won't take so long for you. All I can say, it took about 1 hour roughly. Maybe the second, the third will go faster, but roughly about 1 hour, and this is because I used pretty basic tools. I have no support for this board. I don't have a fancy soldering station. It's just this Chinese piece of crap I bought. It works, and I could do all the things here, and I used soldering paste because you can apply this to the contacts. Just go through with a soldering iron and they will just pop into place. This is a really good paste, and I can recommend it. I bought it on AliExpress. I also ordered some flux, but that didn't arrive yet, and anyway, I wanted to do the project without the flux, and there's only a little situation that you needed. I had some difficulties with the serial converter. where solder between 2 or 3 legs touched, and it was very difficult to clean, but I managed it. So I think if I had the flux, I will just apply it, and then it should have cleaned itself. But yeah, this is what we have now, and this is what we work with. Okay, so let's get on with the construction video. Again, I'm sorry about the quality. I don't have the right cameras for this kind of project, and also for my other heater videos I found out that the GoPro Hero, I have a GoPro Hero 8, is not the ideal camera because the lighting conditions, I'm mostly filming on the inside, and they have a very great effect on the video quality. But on the other hand, it's good because it's really compact, really small, and you can take it everywhere, so you cannot win them all with one device. And pretty much this is it. Okay, so let's go to the assembly video, and we will come back to the flashing part, which is another interesting thing, and you will see how we can load firmware onto these devices. Okay, so I just started my screen recording software also, so I can show you guys what's happening when we try to flash them. So in the descriptions, now actually this is the final product, and yeah, I didn't clean them. I should probably do that, but for now, for what we needed today, they are fine like this. I made two of this, and in the description they say that the first flashing must be done with the J-Link interface, and for this there is also links for the software in the description. But anyway, you will need to go to this site, zigbeer.te, and you will find there this software and documentation pack. You will need to download and install it. I will not do it again because I already did it before starting the video. And from this on, you will need to go to Alex's links in the description and download the... Okay, let's try to do that here. Yeah, and here it is. This is the project I was talking about, and if you want Alex's firmware, you can download this from him, or if you want Quank's firmware, you will go and download them from here. So this is Alex's firmware, and it also supports the LEDs and everything on. You will have all the descriptions here, so I'm not gonna spend a lot of time on them. And also here you have the Quank's firmwares, and there are also for him you can find also coordinator and router firmware here. And here we have the statement that this is also supported, also the chip type and which firmware to use. And also here you probably will have the router firmwares. Okay, maybe back here. Yes. Oh, I was in the same place. And for router, yes, here are the files, and this is the one you should use. I will not download this now because I will only flash with the coordinator firmware now. Okay, so if you have the program, you need to open it, and first I will connect the USB. I hope I'm right in this order, I'm not sure yet. Okay, we will open this configurator, and here we see that our device is okay. The next step is to open the J-Link, the J-Flash. Okay, we will create a new project and start G-Flash. Before we go any further, I made a connection from DuPont wires because the cable supplied doesn't help us much in this case. So you will have the pinout also here on the schematics, and you can find everything in the description. So you will need to make these pins, and this will connect to here on the board. So I made them like that. Okay, so we have flashing. This means I already loaded something to this. and it's Alex's firmware. Yeah, on this also. Okay, so anyway, if we want to flash them, sometimes I found it working, sometimes not. I pressed reset and so on, but anyway, from here we need to choose the correct chip, and this will be CC or just CP. No, CC. Let's go back to Alex's page, and somewhere here, yeah, here it says which you should use, but okay, where are we? Let's find this. Yes, and here is the chip that we should use, but I also already tested this and I find it because I bought the module from here from AliExpress. It says that inside it's another chip, so it's Cc2652. So that shows that one. CC, what was it, 265? Yes, this one. No, something is not okay here. 2652. Yeah, but it's only one kind of chip here. Why? Well, whatever. Let's choose the other one. I don't know why I remember that it worked with that one also. I didn't find any difference between the flashing of this device or the other device. It was the same. Okay, so we'll choose this one, and here we will choose our interface, and it's JTAG, it says it here. Okay, and that's it. And now we should open the data file, and this is where we downloaded the files. So I will open this time, yeah, this is coenx. So we will go to target and manual programming, and I always do first an erase chip. Yeah, and that worked very nicely. And then again, okay, we will go to program, and that's about it. So it's really fast, and now it should work as a coordinator. When you connect it to zigbee2mqtt, yeah, you will see now the LEDs are not flashing, and this, we know that it's coenx firmware. I know for sure it's working, and yeah, this is pretty much about it, and now you're done. We can disconnect this now, we can stop it. Do you want? Okay, we will not. Yeah, did I say yes? I don't know. Anyway, we will close this also, and we will disconnect. Now I don't know if every one of these chips delivered is the same, because Alex says that you will need the J-Link for the JTAG for the first firmware, and you need to be careful what firmware you are loading, so it doesn't have the bootload closed or blocked, because after that you can only flash it with the J-Link. If not, you can flash it with other programs. He goes in his description, if you take a look, that is some kind of Python flasher, which seemed a little bit complicated to me. And I went on to the Tindy's website, and where they are selling their okay, it's not here, no, anyway, it's called ZZH or something like that. I'm pretty sure you will find it. And there they're describing the flashing for an open bootloader with SmartRF Flash Programmer 2. How this works? It works almost the same, but you do not need this. Need this adapter or interface, or what is this? And it should work straight through the USB if the bootloader is not locked. Now, when I made my second stick, at the first one I used this to flash it the first time, but the second one I used only the software from Texas Instruments, and it worked. So I don't know if you really need this or not. I guess it's safe to have it, but for me the second stick worked. I could flash it without this adapter. So for the SmartRF Flash Programmer from Texas Instruments, you can download the software free from their website, but you need to create an account, and then they will send the download link to your email. But how this works, it's pretty much the same. I am not even sure which one is which. Anyway, we can test it. Yeah, this is the Alex's firmware then, and this is the other one. So I found that this is working only if you are keeping the button pushed, the flash button, all the time. So this is how we will do it. I will keep on pushing the button. Yeah, before anything else, you will need to have installed this serial USB to serial adapter driver, because without this Windows will not know what kind of device you will have connected. So it will appear, I think, in the serial ports or in the COM ports somewhere, but you will have a question mark, and you need to download this driver, install it. I tried, I installed it, I ran it, it just gave me errors, it didn't go through. But after that I connected the stick and it just recognized it. So it recognized the adapter. So I don't know why, but this is what happened. But it's working now. Okay, so what I was saying, you need to keep the flash button pressed. From my experience, this is nowhere written, and also Alex doesn't have a tutorial to this software, so he uses anything else, or the J-Link, J-Tag, C-Tag, I don't know, whatever, this one. So we will keep the button pushed, and we will choose, it doesn't matter which software we choose, we have to go here and select the target device. Okay, so from here we could choose actually the only thing which makes sense is this, because this is the basic chip 2652, yes, okay, 2652. Okay, so we will go ahead and try to erase. I don't think you need anything loaded here when you want to erase it. Yeah, it's done, and then we can program it with the, I can see this is Alex's firmware, Takes a little bit more. Yeah, and it's done. And this is the way it worked without using the JTAG first. So I don't know. Okay, let's see. This should reset the, yeah, and the two LEDs are blinking. What are the functions for these two LEDs? When connected to zigbee2mqtt, I cannot show you this because currently my Home Assistant instance is not being used. It will be in the future. We are moving to a bigger house and now everything is taken apart, and I only made some tests. I can say it is working. I can say that the connection levels did improve, not by very much because anyway it was only a test and all my sensors were close, even to the Cc2531, if I'm saying it correctly. I always get confused with these ones. But when changing the coordinator, then the signal improved, but by 10 or 15 units, as Home Assistant is showing them. But the problem is I have it connected directly to the computer, and it is a known fact for these sticks to have it on an extension cord and far away from anything that's metal casing or something like that. Even the USB from the laptop should not be used for zigbee2mqtt, so it's better to use it on an extension cord. But from what I found, it's working fine, everything is okay, and I hope that I will not have problems with it, because I'm relying on these devices for my new project. Okay, I was saying the LEDs, and these only work with Alexis firmware. The green LED will show that the network is on, and it will stay all the time lit. If you have permission join enabled from Zigbee2mqtt, then this LED blinks. So you know, if you, after you paired all your devices, you should restrict the joining procedure for other devices. And the second, the red LED, or whatever color you choose to use, is actually when something is transmitted through the Zigbee network, it will blink. So if you see a temperature is modified on the sensor, this will blink. If you switch on a Zigbee switch, this will blink, and so on. You know what I mean. A door sensor, whatever. So I know that these are working fine. What can I say more about this? Not really much. If you have any questions, yes, if you have the old Cc2531, you can keep all your devices, but you need to change you will need to change something in the configuration. Now I'm not positively sure, but I think somewhere here is described. You can change the emitting power of the module in the configuration, and also you need to change what? I know there is a discussion somewhere, but yes, you need to add, everything is described here, so you should find it in Home Assistant. When you go to hardware, it will be, I think, the last, and it will be USB type, not like the Cc2531. Everything here is described. I'm pretty sure that if you will go to the trouble of building this, you will find the answer to everything here. The pen, yes, the pen ID needs to be changed in the zigbee2mqtt configuration. The pen ID, you have to add some lines here, like baud rate and this LTS CTS false, and then of course you will need to change the port to the new one, and everything should work. I know for me my old sensors worked, but I still had some devices that I needed to repair, but it wasn't really a big deal. Okay, this is it for today. I think my next project on this kind of topics will be a VLAD controller with a relay and with two power supplies, with the node MCU and so on, fuses. I will try to show you guys what I was thinking about, also some problems I encountered while building my first WLED, yeah, this is how they say it, adapter, and how I solved them, and what will be the next step in that project. But for now I don't have all the components, and I'm still waiting for some relays that I just got my refund for them because they didn't arrive, so it's gonna take a little while, but it will be done, I hope, in the near future. Okay guys, thank you for watching. Leave your comments and thoughts in the below the video. Subscribe, like the video, and hopefully we will be back with some more of these projects. I'm also going on with my heater videos because that's my work, this is a hobby, and I hope everyone finds something interesting on this channel. Okay, thanks guys, and I will see you next time. Bye bye.